Well, hello, it's Cliff, a toolmaker from down under. ThreadExpress has been dismantled, and in this video I reassemble ThreadExpress after upgrading the spindle and spindle nose. If you're interested in things mechanical, tips and tricks on assemblies, this could be an interesting video for you. Also, this video could be helpful for folk who are building their own ThreadExpress and want information on its assembly. If ThreadExpress is new to you, it's a thread milling and indexing attachment that fits on a milling machine. You can cut any pitch thread within its range very quickly and easily and do index milling. I'll run a few seconds of video clips now just to show it in action and show what it can do. But if you want detailed information on ThreadExpress, please look at recent videos. There's a whole series of them covering different aspects of this attachment. This video is mainly going to be about assembling and lots of views of the internals. It'll be great for hardware junkies like me who like lots of shiny little bits of metal, gears and threads and bearings. Okay, cheers. So just lift it into place, not too heavy, slip the stud in, turn the turret round, larger parts that I made out of 4140, a much bigger part here. Well, that's the most important part, reconditioned and upgraded with the new spindle nose. I'm thinking what I should do now is put it all back together again, because the other modifications I was looking at doing of making the headstock a little bit lower profile would require remachining and remaking a lot of parts and a lot of work, and the improvements would really only be cosmetic. And there's probably more important things for me to do with an assembled, upgraded ThreadExpress, to be making other videos and testing it and trialing it. So I think I should change my priorities and put it back together now. I was thinking we could take advantage of the fact that the nut is such a thin wall section, the way it's held in the body, is that long term some of these ThreadExpresses might do thousands of cycles and may start to wear the nut a bit loose. So I could put in a couple of grub screws coming in there to just impinge on the nut and squeeze it a little bit out of round to take up clearance. I'm not sure how well that'll work, but it doesn't hurt to put them in. It's only a few minutes work. Just a couple of little M6 grub screws. So I've set the body over at 30 degrees. I can't put them in on center because the wall section's a bit thin there, but at 30 degrees it's thick enough. Set it at 30 degrees and at a 10mm pitch, either side rather, 10mm off either side of the center line should be about right to put those two little grub screws in. I probably only have them slightly tight to start with. No real impinging on the threaded nut, but long term it could be a useful feature. I'm just not sure. Here we are, two little M6 grub screws at 30 degrees, situated at the top front of the nut body, the front being closest to the ratio arm. So looking at the nut and pivot body assembly, I've been thinking about this quite a bit. It's a great project to mull over in your spare time. I'm thinking the best way to attach it is to have it just a tight sliding fit like that. Because it's so thin in wall section, if it was too tight a fit, it would collapse the thin wall nut down and tighten it up on the thread. So we can't have a press fit. And put some Loctite on it. Some of this thin wall Loctite, 638, can handle a really thin thickness. There's the little screws. This is beautiful and silky smooth now the thread's been lapped. I'm just so pleased with how slippery and smooth. There's not even any oil on it and it feels like it's running in oil. If I tighten up those grub screws now, put a bit of tension on them, still loose, and now it's going tight. So there is actually a clearance adjustment there. We can tighten up at some stage in the future if it becomes loose. That might be an option. And I thought, well, maybe those grub screws could indent into little dimple pockets to locate it lengthways. But the trouble is, if you've got a few thou creep between changing directions, that would affect the accuracy of the thread. You really want the nut and the pivot body to be 100% connected. So I think the best thing is to put Loctite on in the assembly so it just fuses as one part, but leave the Loctite away from that zone where the grub screws are so that the bush is not held by the Loctite and it can be closed down on the thread in case that works in the future. I'm cleaning and checking some of the key components to see if there's any wear, and it seems to be running without any serious wear so far. Wouldn't expect it with lubricated bronze running on steels. Some of the key parts are high tensile or pre-hardened steel running on bronze with semi-fluid grease, and there's no real wear so far, so I can put it all together now. These are the key parts for the ratio mechanism that constrain the mechanism from moving in undesirable directions, if you want to look at it that way, but allow it to move freely in the directions that are desirable. Before I put it back together, I'm just giving the edges of the ratio arm a bit of a polish up with some 800 wet and dry and kerosene in a ground steel block, because that's the edge that's taking the weight of Threadexpress when it's in operation doing thread milling. And when you've got a pre-hardened steel ratio arm running in a softer bronze sliding yoke, think of it like a file running in a soft metal part. Any high spots on the surface can wear the part down more quickly, and so a bit of a quick polish with very fine wet and dry makes it much more slippery and less likely to wear over time. Putting it together now, the bevel gears I'll probably lubricate with ordinary multi-purpose grease, but I think a lot of the other moving parts like the thread and pivots and so on, a semi-fluid grease is better because it is more liquid like oil but still thick enough not to run away. Thick oil may well have the same properties. I've just got this big tin of semi-fluid grease and I like the way it clings to the part and yet is quite liquid and low in viscosity. I think I pointed out when I dismantled Threadexpress that it's important to have the headstock and the pivot for the ratio arm in a accurately repeatable position. So I'm using dowels here, there and there, and dowels locating the headstock end plates so that the center line of the spindle and the pivot point of the ratio arm are always in the same position, in a repeatable position, so that the calibration of the different pitch graduations remains consistent. If you dismantle it or you move anything or loosen anything, it's fixed permanently for the life of the attachment. After the spindle has been installed, the ratio arm is installed, and you can see that's how it's attached at the bottom. You can see there a little washer that's just stopping the bronze bearing block from dropping out of that slot. That's the top version of it, but the bottom one is doing all the heavy lifting. That's taking the main load, that's providing the pivot, and the slot is providing the sliding fit of that key pivot. And then the top sliding pivot is installed. You can see the little bronze pivot block there. That's a relatively light assembly. It's just held in place with that relatively light duty bracket. This is just held pinched tight over the body of the nut, and then these screws are tightened up, and the little retaining screw and washer put on top. That's just holding the whole assembly in alignment, but not doing much actual heavy lifting. And the headstock front and back plates can be assembled and tightened up. They want to be tightened up before the taper roller or angular contact bearing adjustment is made. Otherwise, if you tighten them up afterwards, you could pull the end plates in together at the top with the strain of the adjustment. So tighten those up first. I've just used button head cap screws, but they're probably not ideal. I think it would be better to use what they call low head cap screws. They take a bigger Allen key, and the Mark III design has thicker side plates, which is better, and you could partially counter bore rather these low head cap screws part way in, and that is just a cosmetic thing, but it would look a lot nicer. And you could tighten them up really firmly. Conventional cap screws would not look as good because they protrude out like little ugly lumps. So I think low head cap screws would be my number one choice. Button head cap screws would be my number two choice. Something low profile there. You can machine a conventional cap screw down to a low head cap screw. If you machine a small amount of metal off the top and under the head, it becomes a low head cap screw, exactly the same as a low head cap screw. So you don't have to go and buy them. You can just skim down a standard cap screw into a low head cap screw. You might be thinking, use a countersunk style cap screw, and they are really nice and low profile and just flush with the surface of the side plates. But the trouble is, they can constrain the alignment, and you really want them to be able to float into position and then be tightened up. Oh, it's bad light there, isn't it? What's wrong with the light? They really need to be free to float into position with a flat under the head, so that it can be free to align and then be tightened. And the risk of using countersunk cap screws is that it will bias the end plates of the headstock out of line, out of angle, and cause misalignment problems. You need clearance on the threads and a flat surface that can float into position. Now we're ready to assemble it onto the main base plate. So we're going to put some whey oil on there. This is a dovetail version, but it could equally be a box section rebated version. So this edge strip there is doweled on so that it's parallel, the slideway is parallel to the spindle center line. That just dumps into place. You just push it up against there and then put this one on and push it all tight. It'll float into position and then tighten up the cap screws. Now these little spigoted standoff pillars get dropped into position, and the transfer plate carriage or frame gets dropped into position. So that is doweled in place by those little spigots on them. That can be reinstalled in there. Then the dowel put in, that tightened from the underneath. Pay to have a thread in the top of the dowel so that you can screw it, put a screw in it and pull that dowel out, or do what I've done and put a little extension on the top with a little groove in it so you can pull it out with a pair of pliers, but a thread would be a more elegant solution. And then the final stage of the assembly, put these cap screws through to hold that transfer plate frame down. I'll just simulate it so you're not yawning while I fiddle around. So notice those little steel keys there, and here we're going to put the sliding pivot or yoke on there, and the bottom one, I need to lubricate that up, but that goes on there, the steel bearing part, bush part, and then finally the transfer plate goes in. And remember that little keyway there, steel key there and there, that goes into the keyway underneath. And that's really important because what that does is allow the assembly to slide that way by the length of these slots. This isn't the fully Mark III version, but it works well enough. This is a slightly better proportioned in the version 3, but it allows this to move by the distance of those slots for when you want to do indexing without generating a lead or pitch. So it's not moving lengthways, it's just rotating, and the motion is getting lost by those slots. So now we have our adjustment in place. That is the clamp washer, it goes in there, and finally the nut. I need to assemble this more carefully off camera, but this is just showing you how it works. And then finally there is, where have they gone? Somewhere here is, yeah, there they are. The final little part are these three hexagon bolts that go through there. And what they are for is you reach in and loosen those when you want to just do indexing, and so the headstock doesn't traverse, you only get rotation. Now I'll check the camera and see if that all was in the middle of the screen. And now I can put the indexing pin and operating screw in place. See how they work there? Okay, so put them together, put the pin in its hole. You can see that in operation now. It works really well. It's very basic, but you can feel it when you're screwing it in. It come up against the side of the bevel gear. Screw it in until the taper locks up in the hole and it's solid. The whole spindle is solid. You can back it out then until it's free to turn to the next hole and screw it in again, and it aligns and then locks up really solid. One of the final things would be to put the top plate on the headstock. That's mainly cosmetic, although it probably does stiffen up the headstock slightly. bolting that plate on there. Oh, ThreadExpress 2.2, do I have to change that? It should really be now a 2.3, shouldn't it? I'll leave it at that for now. So you can see here the indexing dial. Let's engage it in one of the indexing holes, and there you've got a resettable graduated ring there. Let's just set it on one of those. They're set 30 degrees apart, but they could have degree graduations on them. And you can see, you watch it how it aligns in the hole. Bang on there. I just graduated these pretty basically for the prototype and stamped them on with letter punch, number punches, but that could have fine graduations and be used as an indexer in itself. So that's handy for resetting the 0 and whatever number you want to set. Of course that doesn't apply when you've got the ER32 collet chuck on, but that will be really handy having a collet, especially when you want to hold things like threads and not just having 3 narrow chuck jaws holding the threads. And this is a perfect machine for extending threads in high tensile steel. I think I should do some more videos really demonstrating that, because there's really no better way of doing it. You know, screw cutting it in the lathe up to the head of the screw is pretty difficult. Using a die doesn't really work because it just chips the high-speed steel die trying to cut the high tensile steel bolt. Even CNC thread milling is difficult because how do you get the thread matched up to start with? But on this machine you just set the pitch, wind the knee up until the cutter goes into the valley of the thread and start winding, and you can cut your thread really quickly. I need to really demonstrate that more clearly to people so they can see what a huge advantage this machine is for that type of application. And finally I need to install the sheet metal covers. This one has been hacked around a few times, but I think it's quite a good design. It's a bit rough looking, I should make a new one, but it works well. So this is the permanently installed cover. And that screws on like that. And then there is a quickly removable cover that slips into there. I'll probably carry on with this when it's on the machine so you can better see it, because it has to be in the right orientation to catch the chips in a vertical mode, and also easy to remove the cover so you can make adjustments and things. But this part of the cover is permanently in place, and there's a sort of flexible cover over the slideway here, which you'll see when it's set up in the machine. So to put that little dimple pocket in the spindle slightly ahead of the center line of the grub screw, I first of all put the backing plate on and just spotted down with a 4.9 drill to make a little mark. Then put in a stiff 6mm 90 degrees spotting drill that won't flex much. Then aligned it with that little dimple. Then turned the spindle back a degree or so and cut the pocket with that cutter slightly ahead of it. So now the grub screw is always sort of clamoring to tighten the back plate a little more as you tighten it up. It's preloaded and biasing it tighter. Well, it's probably easier if I do show the covers while it's off the machine. So this is the main top cover, so it's orientated obviously in the vertical mode. Whoa! So they work really well, these covers. They've been hacked around a bit, so they're like about version 4 already, so they're pretty well right. This part here has just got one screw there holding it on, and that slides out. So that allows you to get at the adjustment of the pitch ratio and to loosen these 3 screws for when you want to do indexing without the lead or helix generation. And then that just slips back in there, and that little screw's popped in, and away you go. And I'll won't be able to do that while the camera's running. But look at that. So it's just that. Probably a little knurled knob would be better there, but that seems to work really well. And we've got this flexible leather cover here at the front, which takes up the various positions. That leather apron seems to work really well as well. Just a square of leather with a couple of strips of metal over the ends of it, the edges of it. Thanks for watching that through to the end. Really appreciate your comments below this video. It really helps to motivate me to keep putting in the hours and developing this little attachment. Like and subscribe if you're not already, would be appreciated. Are you aware that Mark Presling has a YouTube channel and he is currently building his version 3. He's also producing the CAD files and drawings that will become available in due course. Thanks for watching. Cheers.